Okay, welcome everyone. I hope that you are having a great Tuesday afternoon. Hopefully you were able to join us for our virtual meetup and you're just checking back to get a little review for yourself. But if not, welcome for the first time. And we are going to begin today by going over our welcoming ritual. So I want you to pick which one of these is your favorite, okay? So I'm going to go ahead and read through them. And then pause the video and tell someone around you which one of these is your favorite. Is it a fruit salad, mashed potatoes and gravy, ice cream sundae with cherry and hot fudge, sweet tea, which is made of tea, sugar, and water, or Kool-Aid mix, sugar, and water? Which one is your favorite? Go ahead and pause the video and tell someone around you. Okay, so I'm not sure which one you picked, but I think that I would have to pick fruit salad. However, that ice cream and Kool-Aid and sweet tea and even the mashed potatoes and gravy, I think they're all calling my name. So I'm not sure which one you picked, but hopefully you thought of a good one. Now I want you to think, what do you think that all of these things have in common? How are they similar? Think about that for a second, and you can either whisper it to your hand or maybe tell a pet. If you don't have a pet, you can talk to your feet. All right. Hopefully your feet didn't get mad at you for interrupting their time on the ground. Okay. So these are all similar because they are all mixtures, okay? They're all a mix of different things, a mixture of solids and liquids for some of them. Some of them are just solids, okay? But let's look into this a little bit more. So today our I can statements are I can identify observable properties of solid mixtures, and I can identify material that will dissolve. Okay? So, before we really get into that, I want you to remember back when we talked about observable properties. What is an observable property? Okay? It's something that you can observe or see or feel, right? So observing means we can use our senses. So you think taste, touch, see, hear, smell to determine what it is, okay? That's different than a measurable property that we would need a tool to help us measure what it is made of, okay? So that's an observable property. And we are going to be specifically talking about the observable properties of a solid. So here are some solids, okay? The one on the right, the trail mix, is an example of a mixture. Okay, we have lots of different kinds of solids that are all there together. We've got some almonds, there's some pumpkin seeds, we have some raisins, sunflower seeds, and I believe these are cranberries, okay? So that is a good example of a mixture. What about this over here? This is salt. Is this a mixture? So this is not a mixture because it's only salt, right? It's not mixed with anything. So here are some more solids that are mixtures, okay, different rocks. So those are different types of rocks. They're different colors, different sizes. Here we have a salad that has lots of different ingredients, okay, all with different colors, sizes, textures, the way it feels. Same thing with the sandwich. I think it's trying to make us hungry. I'm pretty sure that's the goal. Oh dear. Well, that's okay. It's just going to have us go back in. So let's do that. And we were on page 3. Here we go. Okay. So now I want you to think of some ways. So I just described those 3 for you. Some of the observable properties that they had. Okay. I want you to, to come up with some observable properties. What do you think is an observable property? Okay, so you're probably saying color right now. Hopefully maybe shape. Texture, right? How it feels. Okay. We can talk about particle size. We can also talk about attraction to magnets, okay? That is something we can observe. So first, let's look at the particle size. Particle size is the grouping of solids by how small or large they are. For example, particle size can be as small as a grain of sand, or the particle could be as large as a boulder. Mixtures of solids can be separated by size, okay? So by how big or small they are. So let's look at these Legos over here. We can see that some of the Legos are smaller than others. If we wanted to, we could group them into the size that they were, okay? So we put all the smallest ones in one group and all the biggest ones in another group. Okay? We can also observe shape, okay, when we're talking about a mixture of solids. So you might see a triangle, a square, a rectangle. You probably are going to see 3D figures most often. So some of these 3D figures might have an irregular shape, like this rock over here. Okay? So we could separate that rock if it was in a mixture with smooth pebbles that maybe you would throw into the lake, skip on the lake. We could separate it into the irregular shape and maybe the more oval shape. Okay? Color. You can also always separate into color, and these are some rocks that have been organized into groups based on their color. Okay. Texture is another one, so how something feels. Is it rough? Is it smooth? Is it soft? Is it bumpy? Okay, so we could look at, for example, let me think of a good texture. Sandpaper. Okay, so if we had bits of sandpaper mixed in with bits of ribbon, one would feel very rough and bumpy, and the other, those bits of ribbon, would be silky and smooth. Okay, so we could separate it into texture. Attraction to magnets. Okay, so this is another way to separate mixtures. The way that we separate this, guys, when we're talking about magnetic, is it's either attracted to a magnet or it's not. So those are the only 2 groups that it can be in. It is attracted to the magnet or it's not attracted to the magnet. And we see in this picture the magnet lifting up things that are attracted to it. Okay, objects that are magnetic. So you could separate mixtures of solids into different groups based on these 5 observations that we can make, okay? So we are going to keep on going, keep on rolling through here. Okay, because we also want to talk about how something dissolves. Okay, and we want to use these scientific words, okay? So we're learning these scientific words. The words are soluble and insoluble. So soluble means it does dissolve. Insoluble means it cannot dissolve. okay, when you put it into water. So a spoonful of sugar is soluble, okay? So if you think, if you've ever mixed sugar into a watery drink, maybe when you're making that Kool-Aid and you put the sugar in and you mix it all up. So maybe you still say, well, I can taste the sugar grains. That's probably because it's not stirred all the way. If you kept stirring and stirring and stirring, eventually the sugar would dissolve, so you wouldn't be able to taste the actual grains. You wouldn't be able to feel the grains. You would just be able to taste that it was sweeter. The water was sweeter. But if you put grains of sand into water and you stirred it and stirred it and stirred it and then tried to drink it, what do you think would happen? You would be drinking sand, okay? Because that is not going to dissolve in water. Okay? So sand will eventually, once you stir it and stir it and stir it, it will sink back to the bottom and settle on the bottom. Whereas sugar, if you stir it and stir it and stir it, it will eventually dissolve. Okay, so I want you guys to now go ahead and look at the second video that's listed for today, okay? And once you're done watching that video, it's going to give you some more information. Make sure you listen really close, okay? So if the speaker is going too fast, pause the video and go back, okay? And see what the speaker is saying. Once you're done with that, you're going to need to go to today's date and complete the exit ticket, okay? So you're going to go ahead and do that. These are all short answer, so you're going to need to make sure you can put these in your own words, okay? All right, guys, that's it for today. Great job, and make sure you go watch that second video. All right, bye, guys, and I'll see you tomorrow morning.